right, so we're trying to estimate the sum of 12/13 and 7/8. I'll give you guys another 3 minutes to think about that. Pictures, numbers, and words. Okay, on your own, and then you can work with a partner. I'll give you guys another 2 minutes. If you finish that, you can move on to the extension, all right, which is to find the sum of 1/3 plus 2/3 plus 3/3 plus 4/3 plus all the way up to 26/3. So guys, what I'd like to do is to have a couple people come up to the Elmo here and show their thinking on this. I came around and I saw some really good pictures, some really good explanations I heard, okay? And then after that, I'm going to show you how I thought about it as well. I thought about it in a similar way to some of you guys as I was coming around, which was pretty cool for me to see that we're thinking about things the same way. All right, and I saw some different thinking as well, and that is awesome too. So, Alana, would you mind coming up and showing and putting yours up here? Alana thought about it in one way here. Tell us what you're thinking. And as you guys listen and look at Alana, see if you thought about it similarly or differently, and how your explanations were relative to hers. Okay, so Alana, what are you thinking on this?
I noticed that each of them had only one of the each left. So they each rounded off to one, and then one plus one equals 2.
Okay, so how did you get one for like 12/13? How did you think about that as kind of?
Because 12 is only one away from 13. 7 is only one away from 2.
Okay. Did anybody think about it using sort of like pizzas like she did? Hand up if you thought about it like pizzas. Okay. That was one way I thought about it. Okay, so she's looking at that first pizza saying, well, how many slices are in it, guys? In this 12 out of 13, how many slices of pizza do you think she cut this pizza into? Hands. I need to see at least 7 hands up on this one. At least 7. I see 1, 2, 3, 4, 5. How many slices of pizza do you think she drew here? Melanie?
I think she did 13.
13. How come?
Because the denominator is how many pieces you have.
Can anybody repeat what Melanie just said? Albert.
She said that she did 13 pieces because the denominator is how many pieces you have.
Awesome. Thank you, Lana. All right. Daniela, can you put up your candy bars, please? All right. Daniela drew candy bars. Anybody else think of it as sort of the long fraction bars that you split up? All right, Daniela, how many pieces did you split these into? Okay, so she split this top one into 13 pieces. How many of them did she color in? What do you guys think? How many would she color in? Jovan?
I think 12 or 13.
Okay. Exactly. Right? She colored in 12 of those 13 pieces. Okay. Did she eat most of that candy bar, Ariana, if she ate 12 out of those 13 pieces? Yeah, she did. What candy bar do you think that would be, Daniela, if you had to pick one? If anybody had to pick a candy bar, what would it be? Twix, Hershey's, Reese's, Kit Kat. Anybody ever try to split those into 13 pieces?
Yeah, I eat the whole thing in one.
Oh, Jovan's got a solution. He says just buy a king size.
It'll last longer.
Yeah, okay. Those pieces would be bigger, right?
Yes, and you'll feed everybody.
That would be nice.
The bigger the better.
Right? The bigger the better. All right. What's your favorite pizza place,
It's
guys?
delicious.
Favorite pizza place?
Domino's.
Domino's? Golden Pizza?
Little Caesars.
Kelly Square Pizza? Little Caesars?
Yes.
There are lots of pizza places around, aren't there?
I love it.
Okay? So one of my favorites is Blue Jeans. All right, so I thought about this in a similar way to this table over here. So Albert and Alana were thinking about it in terms of pizza. All right, and if I ate 12 out of 13 slices, I would have a stomach ache. Same thing if I ate 7 out of 8.
You have a stomach ache.
I would have a major stomach ache. All right, just save it, just save it for later. That's a good call. That's a good call. I should pace myself. So yeah, so how many pizzas total would you say I ate if I ate all that? Real close to 2.
To estimate 2.
Really close to 2. Okay. So make sure you guys can prove it. Okay? Make sure you guys can prove your work. Do you want to use fraction circles to help with that, or just fraction power cubes? Did you guys work independently, separately on this? Now compare your work with each other and see if you got the same intervals. See if you got it in the same spots. And let me know if you did. Okay? How's it going? Is it good? You work. You work.
Come here, then you're my friend.
That's okay. That's work.
Mister,
Yes.
what do you call it when you
All right, so there's 5, 6, and then you're adding third.
And 1/3.
So now if you had to visualize that, about how much do you have?
And then that, this is alright.
You want the tower?
It's gonna be 1 and 6.
What just happened? What just happened?
One of the things and there to be a hole.
Yeah?
So the answer is gonna be a 1 and 1 6.
So that's the exact answer
It's
then.
gonna be a mixed number.
Okay. So by estimating it between 1 and 1.5, were you correct?
It would, because it's like already past the hole, and then there's still remaining, so it's between half, but still it's not like more than a half.
Cool.
I haven't tried.
So your estimate was right. It was reasonable.
So that'll be. But did he? No. Mine is 180. Because he said he started at the first page. He didn't eat from the cover. Did he eat the covers of the other one?
Okay, guys, you guys. The starter for today, guys, is for you to list at least 5 real-world examples of mixed numbers. Where do we see mixed numbers in the world around us? Okay? So a little bit of silent thinking time to start. Go. Okay, so shoe sizes? Sure. Does anybody have a shoe size that's like half the size, or what are your shoe sizes? 7.5 on IE. Others? 9.5. Albert? 6.5. Mary? 5. Lots of halves. Are these all mixed numbers that we're sharing right now?
Yeah.
Absolutely. Dana, shoe size?
11.5.
11.5. Basketball player over there. Asia? 8.5.
When you have originally you had 4 pies and then your brother eats half of it, and then puts it back in the fridge. So now you have 3.5 pies.
Okay. Absolutely real world, right?
Yep.
Little brother's always eating half of something, right? Jovan.
Birthdays?
Birthdays? Okay, what about birthdays?
What age are you gonna turn? What number is gonna be on the birthday candles?
Okay. Does anybody ever celebrate a half birthday?
No.
No?
Whole birthday.
You guys kind of outgrow that? I feel like when I was younger, I'd be like, I'm 4.5. I'm 6 3/4.
Yeah, exactly.
I don't say I'm like 34 and 1/8 or anything, you know. Cooking. Cooking. Where do we see mixed numbers in food preparation?
In the back of the.
Okay. And why the heck am I holding a box of rice. Dana, did you read my mind? You must have read my mind. Because I was thinking about cooking. And when I was cooking 2 nights ago, I said, hey, we're dealing with mixed numbers here. Let me just flip over to the back of this rice box. Can you guys see any examples of
Yes.
mixed numbers or anything like that on here?
Yes.
Yeah.
Where?
Pretty good.
Where do you see it, Alana?
Next to weight, it says 1 3/4.
Okay. 1 3/4. Mary.
And if you go more down, where it says apple, walnut, flower taste,
Mm-hmm.
right there, it says like 1/4.
Okay. So not only do we have
It's
the,
right there, it's right there.
where? Oh,
4.5 servings. Under, go down.
well, I see this here. She says a quarter. You want me to keep going further down?
Yeah.
Okay, let's see what we find.
It says 3.5
Whoa.
servings.
This is another mixed number. Okay, what I'd like you guys to do now is to turn and talk to the people at your table. Okay, turn and talk to the people at your table to describe your process, how you estimated, and see if your table mates did it similarly, differently. All right, talk about what you guys came up with. Ready? Go ahead. 2 minutes. What'd you do?
I made this into a mixed number,
Okay.
and then I added, and then when I made it a mixed number, it got 1 6, so then I added the 1 to the 6, and then it was 7 and 6.
Okay, thank you, Rochelle. So she turned this 7/6 into a mixed number. How did she do it? Now guys, if you would like the support on the fraction parts, I have got our fraction circles here if anybody would like those. And I've got our fraction tower blocks here. All right, as we add those mixed numbers.
What do you think the point is of making the estimate first?
So you get an idea of, you get a base idea of where your answer should be around, so you know that it's either you're a lot off or you're a little off or you're on the answer.
Exactly.
Well, I count the common denominator and then 11 plus 5 equals 16, and then 3 eighths plus 6 eighths equals 9 eighths, which equals 1 and 1 eighth. And then 16 plus 1 and 1 eighth equals 17 and 1 eighth.